Hi students, till now we discussed about motion in a straight line. So if an object moving in a straight line, suppose this is a straight line road, if you can take an object, let's take this person. So this person is moving in this straight line. So we described this person's speed and velocity and acceleration, and we combine all these and we derived certain equations of motions. So by using these equations of motion, we try to find the relation between speed, velocity, acceleration and displacement. Now let us change the case. The situation is at here. We don't have the straight line motion. Now we need to deal with the circular motion. So that is today's concept, uniform circular motion. So what does it mean? Suppose you have a circle. So in that circle, if an object is moving, so this object is moving inside this circular track, or if you might observe a vehicle, a bike is moving in a circular track, something like the situation. So first we will recall our speed definition. What is the speed? Speed is nothing but distance upon time. And at here I need to recall another definition, that is velocity. Velocity is nothing but displacement upon time. Now, if we can recall the difference between distance and displacement. Distance, it do not have direction, it means no direction. But displacement is having direction. So when we talk about the velocity, we need to observe the object direction. If object direction is changing, obviously velocity also changes. So the velocity change happens two ways: by its magnitude, and another change, it is very important at here, by its direction. So let us understand this in deep. For that, so suppose if I take, for a moment, I am having a linear track, means I am having a straight line. So if I am moving in this straight line, I am moving in this straight line. So strictly I am having only two directions, either the forward direction or either the backward direction. Either I have to move forward or I have to move backward. Now instead of taking straight line, if I take a triangular track, so if I am moving inside this track, so how many times I need to change the direction? to complete one revolution or one round you can take. So I need to change 3 times. So instead of triangle, if I take a square or rectangle, now I am moving inside this track. So how many times I need to change direction to complete one round? So I need to change 4 times. So like that, if we can change the object track, not the object, the track shape. Now it is hexagon, 6 sides. Now how many times should I change my direction at here? So I need to change here 6 times because it's having 6 sides. Now ask a question yourself. Now if I'm moving in a circular track, so if I am moving in a circular track, how many times should I change direction? How many times should I change direction in one round? So this is the question. So to answer this question, if I know the circle is having how many sides, then it's easy to answer, because as I saw in the previous examples, if it's a square or rectangle, it's having 4 sides, so I need to change 4 times direction. If it's a triangle, I need to change 3 sides. If it's a hexagon, I need to change 6 times. But when it comes to circular motion, when object is moving in a circular motion, the question is how many times it's changed the direction. Because when it's changed the direction, so obviously there is a change in velocity. So that is the point we need to concentrate. So velocity change takes place 2 ways. Either it's in magnitude. If the magnitude is changing, velocity also changes. Not only that, if object's direction is changing, then obviously its velocity also changes. Now if velocity changes, now that we can relate it to acceleration also. So acceleration means nothing but the change in velocity by time. Now come back to the circle. So this circle is having how many sides? So if we can know that answer, we can get it. Or if we can say the circle is made up of infinite sides. Infinite. It's a symbol, infinite. Infinite means uncountable. So many. Infinite is a symbol. It don't have any count. Infinite. It means so many sides. It means at every point, the object direction changes when it's moving in the circular motion. So let us see a diagram at here. Suppose this diagram represents a ball. I have taken a ball and I tie up with a long thread, and I am rotating the ball in this direction. So now the ball is moving in circular direction. Now at here you can notice, so if this circle having radius r, this is the radius r, and at this position, so this is the position of the ball. So if this is the position of the ball, you notice that the velocity direction at that point, the velocity is pointing outward direction. So we know that direction called as tangent. Suppose you draw a circle. So to this circle, if you can draw a line tangent. Tangent means nothing but a line which touches a circle at a single point. So that we define as tangent. So if we can take that as a tangent, we can mention that as a tangent direction. The velocity direction is here tangent direction. Suppose if I draw a circle at here, so if it's circle, and if I draw a tangent, tangent means it touches the circle at a single point. It became chord. Yeah, let it be tangent. So if it is touching circle at a single point, so this is represents the direction of the tangent. Now here in this diagram, the arrow marks all are tangent to the circle. Now here you can see, so all are representing different directions. So the finally I can say that if an object moving in a circular motion, its velocity is continuously changing. When its velocity is continuously changing, so we define that as uniformly accelerated motion. That I can write, when velocity direction continuously changing, then the motion is known as accelerated motion. How it is? Because by definition of the acceleration is equal to change in velocity upon time. So this is the definition of acceleration. Acceleration is defined as change in velocity by time. So now here the change is in terms of direction. If the direction is changing, we should say that it's an accelerated motion. So the final important term is at here, the uniform circular motion is a accelerated motion. So when you are moving in a circular track, so you can say your motion is accelerated motion. Acceleration motion, आपका velocity change, where is the change? There is no change in the magnitude but change in the direction. So that's the key term at here. So the direction is always changes in uniform circular motion. Now let us define. Let us write the expression for velocity in the circular motion. Expression for velocity. In circular motion. So this stands at here circular motion. Suppose if I take a circle of radius, suppose this is my circle, this circle is having radius. So the radius, if I mention from the center to the edge, so this is the radius r. Now if I take an object, a small object at here, so it is moving with a velocity v. So velocity of the object. Now if that is the center and r is the radius, now to define velocity, what is the velocity? You can write velocity equal to distance by time. So if we can cut a circle, if we can cut the circle and if we can put it flat, so that becomes as a total circular part, and this part only we call as circumference. So now if you can again join the track again, the line, so it will become a circle. The circle having circumference, so that circumference at here we can take as a distance, because if you can cut the circle, if you can lay down like that, it will become as a straight line. The straight line we can represent as a distance to measure from the starting to as an ending, and if you can fold it back again, it will becomes to the circle. To that circle it will becomes as a circumference. So we can write that circumference as a distance v equal to, it's a circumference upon time. So we can write the circumference formula instead of writing in words. The circumference we can write in terms of as 2 pi r, and the time, here the time is given, the time taken to complete, so equal to 2 pi r upon t. So this gives the formula for velocity in circular motion. So to find out the velocity of an object in circular motion, so we will represent the distance as a circumference and t as a time. So finally, in the uniform circular motion, if an object is moving with a constant speed v in a circle of radius r, and the circle is having as a circumference, what is circumference formula? 2 pi r, and time taken to complete one circle, it means for one round how much time it takes, that we have taken as a t. Therefore we can write velocity v equal to, here it is 2 pi r upon by t, here the 2 pi r equal to the circle's circumference, and t becomes as a time taken. So like this we can define uniform circular motion, and this uniform circular motion is an accelerated motion. Why? Because even though the velocity magnitude is constant, but in circular motion the velocity direction is always changes. That's why we call uniform circular motion as an accelerated motion.